Hi, this is AP Calculus notes for section 5.7. Inverse trig integration. We just did the derivative, so why not do the integration? So what we're going to end up doing is just kind of going backwards from the derivatives that we had before. And so with this first one, this one gives me arc sine. And I'm not going to go into these too much. I think that really right now we're just looking for patterns and trying to fit it into these formulas. And then this one would be arctangent, arcsecant. Hey, what happened to the other ones? Where's arc cosine? Oh, that's right. It just differed by a negative. So instead of learning all the other three formulas, well, all we're going to do is use this one and just balance with a negative. And so it'll just turn out to be the opposite sign. So here's all the derivative rules that we used in 5.6. And just notice once again that the derivative of the arc sine differs from the derivative of the arc cosine just by the negative, and so we just use these three. So we don't need to deal with that other negative or all those other formulas. Now with these, you just have to do a u substitution, but there is a little bit extra layer of complexity. It's this a value, and so we'll work out how we do this a value. So again, number one, which one does it look like it fits? Well, I hope that you realize that it fits the arc cosine. So if I just look at how does this match up? Well, with this, u is simply equal to x. And if I do du, du is equal to dx, so that's no big deal. But I also have this a. A is 1. So I need to work that in somehow. So if I look at this, oh, I take that back. This is 3. So if I look at this, I got the arc sine, and I just take my u, which is my x, and I put it over my a, which is 3. I just plug it in, plus c, done. Okay? So that is the antiderivative of this thing right here. Now if we go over here, what does this one look like? Well, this one looks like that one, arctan. And so if I go ahead and do the same process, a is equal to 2. And remember, it's the square root since I have a squared there. U is equal to, what do I have? I have 3x because it is u squared, and so this would be my 3x. Now I got to deal with a du. That's equal to 3dx. So I need a 3 up here, and I need to balance with a 1/3. Now let's look how this sorts itself out. You still have this 1/3. Then in front here you have 1 over a. Well, you just follow your recipe and go along with it. And then I have the arctan. And then what do I put inside? Well, I got my u, which is my 3x, and then I put it all over my a, which is the 2. And then I go plus c. There it is. Clean it up. So I get 1/6 arctan 3x over 2 plus c. Now what's nice about using these formulas is that if you look in the back of your book, there's tons and tons of antiderivative formulas that you just have to plug pieces into. So if you can start getting the hang of this, then you should be able to do any other antiderivative as long as you have a formula that sets it up for you. Okay, so let's move on. Now with the next example, this doesn't seem to fit exactly like the other ones. However, I kind of see maybe a function and its derivative. If you remember, the derivative of the arc cosine is -1 over square root of 1 minus x squared. So this one doesn't fit this same exact pattern. It is a straight u substitution though. So if I let u equal the arc cosine of x, du from your previous notes, this would be 1 minus x squared. I put the negative in there since it's arc cosine. And so if I look at this, yeah, I got that. I just need the negative. And so I need to balance a negative. So I don't have to fit the pieces exactly like I did before, but I have the negative integral of, well, this just turns out to be u dx. So this is u du. So it's u du. And so this is equal to u squared over 2 plus c, which is equal to the arc cosine of x y squared all over 2. Oh, and I don't have plus c because it's a definite integral. So I got to put back my limits of integration that deal with dx. I forgot I wasn't putting them in because it was with the u. And so I'm going to go from 0 to 1 over the square root of 2, which is square root of 2 over 2, if you remember that. And so the arc cosine, what cosine value gives me a square root of 2 over 2? Well, that would be pi over 4. And we're going to square that. So that'd be pi squared over 16. So I get pi squared over 32 because of this 2. Minus, if you plug in 0, yeah, I get a value if I plug in 0. And this would be pi over 2. So I get pi squared over 4. So I overall pi squared over 8 when I put that in. Get a common denominator. That's 4 of those. And it looks like I'm getting a negative answer here, so I think I made a mistake. And if I look back, I did. I lost my negative here. So then this would be negative. So this would be negative, and this overall would be positive. This is 4 squared 4 over 32. So then I'd end up with 3 pi squared all over 32 as my final answer. Okay? So that works out. Sometimes, yeah, I make mistakes too. And if we look at this next one, does this fit any of these patterns? It kind of looks like this one, doesn't it? Well, yeah, the u here would be x minus 2. If I look at my a, common mistake, people say 3. Nope. It's going to be square root of 3. So then this one would just be du is equal to dx. So no big deal there. And so if I plug these pieces in, it's 1 over the square root of 3 times the arctan, inverse tangent, of u over a and then plus c. Oh, I got a definite integral again. I keep on missing that. So then this would be from 1 to 2, and that's not there. So if I plug these in, well, you can plug that in and sort that out, and I'll show you the answer. So I get pi over 6 square root of 3. Because if I plug in 2, I get 0. And if I plug in the 1, this would be a negative 1 over square root of 3, which we found out earlier was negative pi over 6. Negative negative makes positive. So that's where we're at. Moving on. If we look at this one, does this fit any of these patterns? Well, a little bit. This one right here. Well, possibly. Let's see. If I let u equal to the sine of x, then du is going to be equal to the cosine of x. Oh, I have a function and its derivative. And so then I can plug those pieces in. A is equal to 1. So if I look at how this sets up, I go from the integral. So then this just fits into this category, but I guess I could have gone straight to the formula. 1 over 1, and then I get the arctan of u, which is the sine of x, all over a, and my a is 1. I should write that down for you. And I'm now back in x, and so I can put the limits of integration in here. So that would be from 0 to pi. And if you plug these values in, I'm going to get 0 minus 0 equals 0. We should take a look at the graph of that one and see that if it's equal parts up above the x-axis and below the x-axis, and see if those areas cancel each other. The next one, this one fits into possibly this pattern too. Not so obvious though, is it? So if I try to do this, well, I can let u, well, let's do a first. A is equal to 4. U is equal to, what do you think? E to the 2x. If I square this quantity, I'm going to get e to the 4x. And then I still need my du, and this seems to work out. So I get 2 e to the 2x. So write it down as it is and then chain it off. So that's where I get that thing. I need a 2, so I got a 1/2. This fits the arctan. I already have the 1/2. I need the 1 over a. And then this is going to be arctan of u over a e to the 2x all over, what do I got? A, which is the 4. Indefinite integral, so now I can put the plus c And then this is 1/8 arc tan e to the 2x over 4. There we go. And then the final one here, I've been kind of hitting you hard with the arc sine and arc tangent, really the arc tan. But this one looks like it fits under the category of the arc secant. So let's see if we can set this up. So I have a u is equal to 3x. That seems to fit there and there. Good. And then a is equal to 2. So I need a du is equal to 3dx. I need a 3, so I got a 1/3. So here we go. Plug it in as we see it. I got a 1/3, and then I got a, I need a 1 over a. So I got the 1/3 from the balancing, and then I got the 1/2 from our formula. Those get multiplied together, and then I get arc secant of absolute value of u all over a, and then that's plus c. So this is simply 1/6 arc secant 3x absolute value over 2 plus c. I would look at some of these graphs too and make sure that you could do some of these definite integrals with your calculator. You always need to practice that. Now if you look at page 383, you have a bunch of formulas now. These are all the formulas that you're going to need to know for the AP exam. As far as derivatives, integrals, I think this is just integrals, but that's, you get the idea. Okay? So you know a bunch. And then here's the homework, and we'll also probably do some WebAssign in class. Thank you very much. Plug and chug, find the formula, put it in to the right form, and don't forget to write this stuff out. I would definitely write it all out. Thank you very much.